Drugim? Bezpiecznie? Drugim.
Przypominam, pracy nie bardzo. Ale z poprzednich prac. To już są koledzy z przyszłej pracy. To fakt. Nie pamiętam z czego, ale kazał wszystkim wyłączyć, nie działało. Kiedyś tak było, no, 1000. Nic nie działało. Ja powiedział, albo wyłączycie, albo kończymy prezentację. Dosłownie. This is not the job.
There you go. Ah. Kannst dich setzen.
Okay. Hello everybody. Dzień dobry, witam wszystkich. Cieszę się, że tak licznie przyszliście. Po angielsku będziemy mówili, dlatego że mamy gości niemiecko i anglojęzycznych. Jako, że niemieckiego nie znam, więc będę mówił po angielsku. Okay, so I'm happy that you gathered in so big number. I have doubts, to be honest, when I have like a great idea to organize that like a month ago, and I'm happy that it went well so far. So we start the community, C++ community in Poznań. This is kind of branch of Wro.cpp, a community from Wrocław, and we will be trying to do similar thing as we are doing in Wrocław. And today our sponsor is IVU Traffic Technologies. We have some representatives from, and also a first speaker, who will tell you something interesting about their technologies. But also there are people who are here to meet you or to give you a chance to meet them and to get some information about new company that will be building something in C++ in Poznań. So the agenda for today is short introduction, my boring speaking, and some like 3 slides about the IVU company. And after that, Axel will get into the stage and will tell you something more interesting about C++. So going from C++ 03 to 20, while building and extending ORM in their tools, as far as I understood. After that, there will be break and some food. So that will be the excellent time for some kind of networking. So if you don't know each other, that will be perfect moment to meet and to speak about C++ and the future of C++. And after that, I will take the stage and I will tell you something about CPP2, like the new syntax for the C++ proposed by Herb Sutter, as it was like announced lately. I will share with you some my first thoughts about it. And we are streaming, and I just realized that I failed here because something went wrong with the streaming. But what I would like you to do is, if you have a cell phone, and I believe you have, please send information to your buddies that, hey, I'm on the Poznań.cpp meetup. If that's possible, just let everybody know that something is going on in Poznań. So we are like on the first meeting. I hope we will manage to organize next meetings, and I believe that's highly probable that we will meet often in Poznań, as well as we are meeting in Wrocław. So if you or any of your companies are interested in organizing a meetup, just let me know and I will do the rest. If you want to support the community, there are at least 3 places, or maybe 4, where you can support us. So the first one is a LinkedIn page of the Poznań.cpp community. Then there is a Facebook for the Wro.cpp. If there will be need, we will create another one, but currently maybe it will be enough. And the YouTube channel also for the Wro.cpp, and it collects all the videos. But if there will be need, we will create a separate one for the Poznań.cpp community. If you are willing, you can also support us financially. So you can go to the Patronite, find the Wro.cpp, and become a patron for us. There's like Platin patron, which is Adam Badura. I promised him that I will be speaking about him on every meeting, just because he's sponsoring us. So I did. So enjoy the presentation. Just give us like a minute to switch the cables and make everything work, and we'll start the presentations. Okay? Thank you.
Das geht in Präsentationsmodus, das ist jetzt nicht gespiegelt. Oder?
Okay.
Nee, doch nicht. Warte mal. Muss man das wieder einstellen?
Wäre mir aber nicht wichtig. Das
Ja, ich brauche das aber nachher. Dann
Okay.
würde mich das nerven, wenn das nicht funktioniert. So, jetzt raus. Sehr schön. Und jetzt sollte das da und das da.
Super. Okay. Do you hear me? Yeah. Works, right? Okay. Thanks a lot for having us, Philip. Thanks a lot for the introduction. I will just take a few minutes, a few slides to introduce our company to you. And I'm sure that those kind of company presentations you've seen and heard a lot, so I'm not going to take a very long time and get quickly to Axel, because you're here to hear what he has to say about C++. But just to give you a very, very short introduction what IVU Traffic Technologies is. We are a software company based in Germany, in Berlin. So me and my colleagues who came this morning from Berlin to join you here in Poznań today. And we develop software for public transport companies. So you have to think about bus and train companies, big and small, in Europe and in all over the world, that need software to manage and plan all their vehicles, all their drivers. This is kind of software that we develop and sell to public transport companies. like I said, we're based in Berlin, and we have customers all over the world. The green countries are the countries where we are having customers at the moment, and the small blue dots are the offices that we're having at the moment. And you might see that, yes, there are quite a lot of customers in Poland as well, but not yet any blue dots, not yet any offices. We're here actually to change that. We're hoping to build something here in Poznań, and this event today might be kind of the start of IVU in Poland, in Poznań. Like I said, we are developing software for public transport companies, and this is like the overview of all the products that we're offering. That's a lot, and I'm not going to get into the details of all of it, but what you can take away from it is that this is kind of a timeline through the processes of public transport companies. So it starts in the beginning with the planning phase. So you have to make a duty schedule or vehicle scheduling, and then you have to dispatch and decide which driver, for example, goes on which vehicle and goes on which route. All this is done in the first segment, in this planning and dispatchment part. And then we get to the operation part. So there we have the fleet management, ticketing, passenger information. So those are the kind of products that you as public transport companies, customers are probably most aware of and have your daily contacts with, because you buy tickets, you see the information displays on the bus stops, and from now on, when you see those things, you should have in mind that the software that is in the background doing all the service for this is usually software that we develop at IVU. To give you like a very short, some very short examples of customers that we are having. BVG, the public transport company in Berlin, where we're based, is using our software. Also, the long-distance trains in Germany, and in Poland we have the WKD and PKP. Those are two of the main public transport companies here in Poland that are working with us together and that are using our software. So, yeah, like I said, I wanted to make it very, very short. And Axel, I'm going to give you the microphone right now. If you have any more questions about us, about me, feel free to get in touch with us in the break or after the event. I'm very looking forward to that, to talk to you. Axel, now it's your time. Thank you.
Hello everyone. Hello everybody. Yeah, I'm happy to be here and to tell you about developing software at IVU, the company Henning just presented. And yeah, I hope it's interesting for you to hear what we do, why we do it, and how we do it. Because this is streamed, I will use the laser pointer. And the abstract of the talk, I think you read it when we initially constructed our object-relational mapper, the ORM, in about 2009. We were limited to the C++03 feature set. And despite these limitations, we achieved most of our goals. During the following decade, we continuously improved and extended the ORM to achieve better usability, prevent errors, and increase performance. And some new C++ features introduced with the following standards helped us with this effort. The talk will give an overview over what we did, why, and how. Parts of it, because covering everything would take much longer than is planned for today. And I will also illustrate C++ features we still desire. Who I am? I studied computer science at Technische Universität in Berlin and worked in network security before joining IVU Traffic Technologies, and have been working there since 2004. Currently, I'm a senior architect in IVU Vehicle. You saw the slide, but maybe you don't remember. It's in the middle where the vehicles are dispatched on the trips they are going to do. And as a C++ expert, one of my focuses is on exploring modern C++ language features to achieve good performance and high quality. And if you have comprehension questions in between, please ask. Discussion we should do at the end. And sorry, I do not have the time to explain everything about ORMs, so bear with me that some things are very condensed. Okay, let's go. The system. IVU Plan is, as Henning already said, an enterprise resource planning system for public transport companies. It has about 6.8 million lines of code in C++, and that's not counting empty and comment lines, so that's code. It has 3 million lines of code in Java and about 700K lines of SQL code. We have more than 700 tables in our database, and the system has been developed since before the year 2000. So it's an old system. But it has been continuously extended and refactored. So that's not that big problem as it sounds. To give an overview over the system structure, it's a classical 3-tier architecture. In the bottom we have the database tier, and then we have the middle tier from the data containers up to the business logic, and then the presentation logic in the 3rd tier on top. The data containers provide data structures for table rows, and they are generated from annotated database metadata. We do that primarily to achieve type-safe primary and foreign keys. Other than that, there are simple data types used, the types the database knows about. Above that, we have a database access layer, the basic database access, and that enables type and structurally safe load and save for the data containers below. And above that, we have an enhanced layer to allow for the type-safe construction of select statements together with their where conditions, allowing to dynamically assemble queries at runtime while preserving correct bind variable assignments. And then the part I want to talk about next is the object-relational mapper, which allows building a graph of business objects and traversal of edges on one-to-one relations and to many relations. And the ORM maps also maps simple to elaborate data types and provides for efficient load and save. Above that layer, we have the business objects, which are implemented using the object-relational mapper, and the business objects contain those parts of the logic pertaining to a single business object and all objects reachable from there. So our philosophy is a navigatable object graph and not a service-oriented architecture. Above that, we have data access objects, which bundle all database access strategies which belong to a certain business object class. And above that, the business logic implemented in services and business objects. The object relational mapper itself, here counted together with the transaction context, has about 120 klog in header files. So you can see it's mostly implemented in templates. And we have a 12 klog CPP, so some parts are not templates, but only 10%. And if you look at the layers which use the object relational mapper, it's about 1 million lines of code. So it's the ORM is just a small library used by a large business logic. Okay. The ORM, difficult word. What does it do? It allows to retrieve graphs of objects from the relational database tables and allows to navigate this graph of objects in memory. You can change object properties or references between objects on the objects and then save the objects back to the relational database. To do that, we need to declare a mapping from the tables and columns to objects and data members. And then we want to define interfaces for the objects with elaborate data types not existent in the database. So we have value types for length, mass, volume, speed, and anything else. And for example, constraint strings like trip numbers. We talked about the business we are providing. So they have special requirements on the format of trip numbers. So we don't have simple strings there, but elaborate data types, enumerations, and other things are mapped on the interface of the objects to the database tables. For the IVU, the goals were longevity first, at least 20 years. I said we started developing the software before 2000, and so we are looking at very long life cycles, so the ORM had to provide this kind of longevity. And therefore it needs to be easily maintainable, and the technology which we are basing on should be available for a long time. We also need very, very good performance together with good scalability, because we have many objects, large sets of children on, or referenced objects, like customers having 10,000 vehicles, 200,000 trips a day, 10,000 network points like bus stops or tram stations. At the same time, we want to achieve ease of use. So when coding with the system, we want a minimum amount of boilerplate code. It should be easy to learn and to apply, and it should result in a very low user error rate.
Wait a second. Can you hear everything? It's fine? Okay, because mic there.
Yeah, it's not good?
No, it's not working probably. Yeah, so continue, please.
Okay. You got the sound somewhere from somewhere else? Okay. Very, very good. Okay. And we need good integration with the legacy code, because when we started in 2009, we already had at least 1 million lines of code, and we needed to have this new system work in conjunction with the old code. And also, using templates, can result in long build times. So that was also a goal, to keep the build times acceptable. We took inspiration from J2EE, Java 2 Enterprise. What does it mean? Whatever. And it has services, service registration, service injection, business objects, data access objects. And then it has Hibernate, well, which is one of the the most prominent persistence provider in Java. And it delivers object-relational mapper, business objects, or the facility to build business objects. And these technologies rely heavily on annotations and reflection. C++ has no reflection yet, I may say. And it has no annotations. So what do we use instead? We used, and we are still using, type defs, templates, member pointers, member function pointers, and static methods to provide the meta information which is provided via annotations and reflection in Java. Okay. So just a small example. Here a little graphic illustrating a very, very reduced part of a traffic network. You get network points like bus stops or tram stations, and you get a link between the stations, and these are directed links, so it's a bit senseless because you can only travel in one direction and you can't get back, but for example, in this context, that should suffice. And I have brought 4 classes, 4 business object classes, a network point, a link, a stop post name, and a division. Division is like the bus division, the tram division, the rail division of a public transport company. And how are business objects structured? They have flat attributes like a name or abbreviation, and as it is stored in the database, they have foreign keys, and these foreign keys reference other objects, like this division, the network point, the data, the row in the database of a single network point references the division it belongs to. And therefore, we need reference attributes because we want to be able to navigate from the network point to the division. So we have a type reference to 1, which is mapped to a certain foreign key in the database table of network point, and it can be resolved to the division object. And that's a to-1 relation as annotated here. We have reference to many relations, which are these, annotated with n. And in the database, they are modeled by inverse reference directions, because the link has the foreign key to the network point, but in the object model, we want to reverse the direction. We want to go from the network point to the links which arrive at that network point, or to the links which depart at the network point. So the reference direction in relational database is inverted, and so the relation needs to be mapped to the foreign key of the reference row link in that case. And for the stop post name, we have the parent to children relation, which is a subclass from reference to many, and it adds the management of the ownership on the parent object. So when a network point gets assigned a new stop post name for a certain usage, like traveler information system, there you want, maybe the public transport company wants to display a different kind of string, then for another usage, you can add a stop post name, and this stop post name is a record in the database which belongs to the network point, and it has some kind of ownership. There's some kind of ownership relation between the network point and the stop post name, and so the network point is the parent and the stop post names are the children. And so we have the ownership management as additional feature in the reference. So when we add a new child, then the child's parent reference is automatically set. Okay, so how we put that into C++ code. So I brought an example. For the network point, we have a structure which contains all definitions for references on the network point. And for example, we have here a constraint foreign key reference division ref, which lists the referenced object type and a reference, well, an ownership, technical ownership attribute, which is weak, which means the object held via a weak pointer and not via an owning shared pointer. In contrast, the strong relationship type means that the object is managed by a shared pointer, so to reflect the ownership relation in this case. So we have the constraint fk. Fk stands for foreign key. The foreign key reference constraint because the database has a constraint which enables, which disallows dangling references, and this is reflected in this name because the behavior of the framework changes upon having this constraint. And we have, for the stop post names, we have an inverse foreign key reference to the class stop post name, and the parent is the network point, and it's a to many reference, and it's managed strongly, so it's kept with the shared pointer. The third type of reference we have, it's also a reference to many, like the stop post names, but here we have two references which are, from their parameters, are equal. They both go from link to network point. It's a to many reference, and the reference type is weak. But we have two different kinds because we have the arriving links and the departing links. And to be able to separate those two, we use tagging, type tagging. So we define empty structures just to have a type, and we put them here to be able to discriminate between the arriving links reference and the departing links reference. And how it's used, we'll see later. Okay, example business object. How is the network point implemented? It inherits the refs definition, but that's not very important. It's to ease the access to the definitions, but it's not strictly necessary. I have omitted the derivation from the interface in this example. You need to put it there in your head. Okay. I hear the speakers. Okay, so in the private section of the network point of the business object implementation, we find the reference to 1. And here it uses the division reference, which we defined on the previous slide, contained in this network point refs structure. We have super, which is a shorthand for the superclass, which we define in the standard base class, which I omitted from this slide. Maybe I should add it, but I forgot. And we have, this is interesting, we have something here. It's a DC network point FK division. And the comment says, gives a bit of explanation. The DC is a shorthand for data container. You remember this is the level directly above the database, where the rows are just, the database rows are just put into C++ structures or classes. The FK stands for foreign key, is an abbreviation for foreign key. And the DC network point is code generated from database table structures and meta information about the mapping. So we have a base level of mapping from database tables, table structures to C++ data structures, but these are plain mappings, but they contain already type-safe foreign keys. So this foreign key is a global static in the DC network point class, and it contains all the information about this foreign key. So from which table to which other table, how the column is named, and stuff like that. And so we can define the reference to one just like that. It's not as smooth as annotations, but it's very close. So we have a member variable division. So if you want to access this division, we implement just a getter, for example, get division, and this division getter just forwards to this member variable and calls the get method. And interestingly, it provides itself as a parameter. And this giving this as a parameter, allows for the reference to get to the information it needs, namely the value of the foreign key. Because the value of the foreign key is contained in the data container. The data container is a member, not shown on this slide, of this network point impl. And because the reference needs the information which key to resolve when get is called, it needs a back reference to the business object. Okay, that's one of the tricks we did. Because we avoid making the reference dependent on the network point impl in a way which needs to be initialized on construction and would take up space in RAM. So it's just dynamically given with each call to the reference. We provide the network point impl. And reference to many look quite similar. In this case, we don't have the foreign key because the foreign key is already contained in the reference specification. Okay. And these getters are implemented similarly, just here, symbolized by the 3 dots. You can imagine how this is done. And parent to children is a bit more complicated. It's like a reference to many, but it also has the information about the implementation of the child. And this is also interesting, it has a member function pointer which allows the reference to set the network point, the parent reference, on the stop post name when the stop post name is assigned to a network point. So that's also a pattern we used, member function pointers as non-type template arguments. Okay, how is the reference to one declared? It's just the template. It has the reference tag as a parameter. It has the standard business object impl as a parameter, or this concrete business object impl, which needs to derive from standard business object impl, therefore the name. And then we have this complicated looking expression. It's a foreign key implementation depending on several types which are extracted from this parameter before, and it's just a const ref on this foreign key global static variable. Or no, it's a static member of the data container. And we have some defaulted variable here, parameter here. That's not important at the moment. Okay, so what we see is we use non-type template arguments, especially references to global statics, though it's class statics, but they are globally reachable, so yeah, kind of global. We could not use auto for non-type template arguments because it's a recent addition to the C++ standard. We had C++ 03, and that caused the requirement to give this parameter, because we need this parameter only to be able to specify this type here. If you could write auto in this place, we wouldn't need that parameter. So future work would be to convert these things to use auto for non-type template arguments. We could do that because it would allow us to drop other template arguments, a standard BO impl in this case, but it would not help us because it would not help us that much, because the congruency requirement would still be there, because this foreign key has to match the type, the DC type, the data container type, which is used in this business object class. And to prevent long template error message storms in the compiler output window, it would then be quite nice to use concepts to prevent that and to have better error messages. And when I look back at the time I implemented that 12 years ago, I had a lot of compiler crashes because the tools were not very stable, and if you had mismatches here, the compiler would just cease to work and say internal compiler error. And it was a bit tricky to get all these things to run, but it wasn't that hard on the other side, so on the other hand. Okay. Now another trick. You've seen the getter. The get needs to get the referenced object from somewhere. So how can a reference fetch a referenced object? Where should it get this object from? Or a vector of referenced objects? They need to come from somewhere, because the fetch is triggered when calling the get, and the reference is not resolved. And as you have seen, it's always forwarded from the referencing object. Yeah, we also have prefetching now, but we try to stay simple. So when the reference gets the get call, the get is called on the reference, it needs access to the data access object, because the data access object is the only place in the system where we can retrieve an object by giving its primary key. So the data access object provides a find by primary key. And so we need access to the data access object. The ID type suffices. We can just select the proper data access object, because the data access object is type specific. We have one data access object for each business object class. That's the difference to the Java world, but it's easier for us. And some inverse references need type tags. We had seen this for arriving and departing links to separate them. I will show how that works in a moment. But first, let's talk about where we get the DAO from. Because all information we need must be in the referencing object itself. Because the only thing we have is the business object, and we call get. So we need some kind of context. And to put a pointer to a specific data access object into each reference would be very expensive in RAM and setup cost, so we didn't do that. Instead, we wanted to use one pointer to a component-specific entity resolver object in each business object, and this entity resolver should be able to like demultiplex the call, the find call, which is typed by its ID. And to produce such an entity resolver, the first entity resolvers we wrote by hand, but it became very quickly very tedious and error prone. So we devised a way to synthesize entity resolvers. And we do that by listing all access types needed for all references in the respective component. What this means, we come to that. We have a standard access by ID. It's like find by ID, and the ID type selects the data access object, and the access is just a forwarder to the proper data access object. And we have to bind special access methods by foreign key depending on the reference tag to a specific data access object method. Okay, the access definition maps a reference tag to a specific finder, and it does that like so. So we have, for example, the link access, and it's defined as a generic access on the link DAO, which provides the standard find methods, find by ID and find by set of IDs. And we have some special accesses, and here you see the arriving links reference tag is bound to the find arriving links method in the link DAO, and the departing links reference is bound to the find departing links DAO. And here you can see, again, we're using member function pointers as non-type template arguments, and we define a type, which is the link access. And then we produce a resolver, and the first attempt was C++03, a resolver chain. We didn't have parameter packs, no variadics at that moment, so we used the recursive template, and the recursive template resolver creator chain gets the first access, and the second parameter is again a resolver creator chain, and it gets the next access, and so on and so on and so on. And you can imagine getting a lot of closing angle brackets in the last line when there are many accesses needed in a resolver. And this resolver chain produces a chain, an inheritance chain, starting with the base class, which is the default parameter for the second parameter omitted here. And then we just have the resolver creator chain, abbreviated as RCC here, and it inherits from base, and it uses using base find by ID. So we need to seed it here. It's like we never use this signature, but we need it because we want to have using on the base class. So we have to have the signature here, and then we pull it down, and we implement find by ID with our specific ID in this access, and then we inherit, and we have a resolver creator chain division access, which has this as the second parameter, and then it inherits from its second parameter. It has the using, it delegates the using to the top level, and then implements it specific finder. It works. It results in very long type names and many intermediate types, but it works even with many accesses. But the overload resolution needs to traverse the chain until it finds the match. Yeah, sometimes to get build times down, I wished I would have been able to profile the compiler itself. Okay, then came C++ 17. Well, first came C++ 11, and we had variadics. And then I said, well, that's the nice thing. We should convert the resolver chain into a variadic implementation. So producing a variadic resolver where we just can list the access classes as sequence, comma-separated sequence. Looks very nice and produces this kind of inheritance hierarchy. So we have only one class, and it derives from all listed base classes here. But there is a problem, because the first try to convert it to a variadic template failed, because variadic using was not available in C++ 11. And without variadic using, I could build this inheritance, but I could not overload in the derived class, because these would not be visible. Okay, so I had to wait 6 years until C++ 17 solved the problem with variadic using. And now we have variadic using, and the implementation becomes very simple. Okay. For an example, the traffic network components resolver has 110 access classes in the variadic resolver. Before Visual Studio 2017, we always got this C4503 warning because a decorated name length exceeded 4090, I don't know, 3 characters or something like that. Luckily, Microsoft dropped this warning in Visual Studio 2017, so this is no longer a problem. And the conversion of the chain into a flat multiple inheritance reduced the binary size by a lot less than I expected, 0.5 to 1%, and the compilation time became a bit shorter, but not really that much. But it looks nicer now. Okay. Let's talk about transaction handling, state transitions. I don't want to dive deep into transaction handling, but when transactions start and transactions end and objects get saved, we had the need to do similar things on all references, just to make the state transition. Before save, we needed to do something. After save, we needed to do something. Just notify all references, oh, your object has just been saved. And then they switch internal state. After end of transaction, we tell them you can't resolve anymore because the transaction has ended. So these state transitions we need to apply in the same way on all references. Okay? Reflection. If we had reflection, we would have used reflection. But we didn't have reflection. We don't have reflection yet. So we implemented something I call reflection for the pool. And that's a static method, in this case called getReferences, and it returns a reference description list. And what we need to do is fill this implement this method. And yeah, okay, I show how it's implemented in a moment. This is a reference description where the virtual functions for these state transitions are listed, like update, pre-detach, uninitialize, notify saved. And this is also a pattern we use very often, is combining templates and pure virtual methods. Like it's a template on the business object type, implementation type, and this defines an interface. And when we construct the reference description list, we add, oh, what's that? A member pointer. Okay, so we use a member pointer to specify the reference, and we list all references contained in the object. So now we got reflection for the poor, because now we know what the reference members are contained in this implementation. Okay, and then we can just work on all references. In theory. In theory, there is no difference between theory and practice. In practice, there is. Guess what happens? What happens? The getReferences method is not updated when a reference has been added. Standard error. I have a reference. I can use the reference. Everything works. But the state transitions, they break and boom. Oh, crash. Much later. What can be wrong? And it took us some time to debug. And the developer came to the architects and said, I have a problem. It doesn't work. It crashes here, and the data is not saved, or the data is wrong, and I got wrong state in the database. I don't know what happened. And then we ask, did you list the reference in the reference description list? Oh no, I forgot. And after the 5th, I decided I want to make sure a reference is contained in the return value of getReferences. But how? Okay, so I came up with a check, because when a developer adds a new reference, the least thing he or she will do is call get on the reference, because he wants to use the reference, otherwise he wouldn't have added it. And so in the get implementation of the reference, I put a check, which is a runtime check for the correct configuration of the referencing object. Okay, how is that implemented? The check iterates over all references and asks the reference description to check the reference. And if a reference says, well, I passed the check, it returns. Otherwise, if no reference has said, I passed the check, then it throws a configuration error, and the developer is reminded about what he forgot. And it says, well, this is not in reference description list. How is the check done? Well, the reference description, as you remember, has the member pointer. So we can apply the member pointer from the description to the given referencing business object, and then just check if it's the same pointer as the parameter given as this, and this is the pointer to the reference itself. Just a simple pointer compare. And if they are equal, oh yeah, we found the matching reference description entry, and then we are sure, hey, this reference is in the list, everything is okay. And that saved us so much time. Great. Okay. So, what was the most important takeaway from building the system is we build heavily on structural similarities to avoid boilerplate code. Make things which are equal look equal, but differentiate when necessary. So we have a find by ID method, not a find by division ID method, because the difference in the signature name would prevent generic code. So, for example, let's take the data container. Each data container of the 700 plus tables we have, 700 data container classes, each one defines a member primary key. And the primary key has the specific type of the data container. And so, if we want to fetch an object for which we have an ID and we know the data container type, we can just construct a generic select statement. Construct a select statement, we type it on the data container type we want to fetch. We build an expression syntax tree. We put a where condition onto the statement in which we assign, in which we use overloaded operator equal to build this expression. We put the division ID as the value. We bind it to the respective column, and then we just can execute the statement. And this is the generic code which is contained in every data access object. So we have a template for data access objects which works for all data containers. Easy as that. And as you have seen, we can use the ID type to select the proper data access object. And the resolver find by ID, we have seen the inheritance chain or the overloaded pattern just to select the correct data access object, which just executes this specific code, which is the same for every object. So all structurally similar things can be written as templates and simply be instantiated for every data container type. Done. Okay. Let's look at what we could potentially improve in the future. There are still a lot of things to do, and many of them are possible with C++ today. We could, for example, use unordered set and unordered map instead of set and map, but we find out that it's not always better in performance, so we're a bit reluctant currently. We could replace many classes from Boost, like shared pointer, tuple, stuff like that. We could replace recursive templates with variadics. We have seen the access definition, it's still a recursive template. You could just variadize it. Huh? Use parameter packs. We could remove necessity for type defs, because since we have decal type, we can calculate types as needed. We can use more auto to infer types and reduce the necessity to have the proper type defs in the proper places. But we have decided not to do it everywhere because it hampers readability. Because sometimes you don't know, just it's auto. Okay. And we want to keep sufficiently good compiler diagnostics, use concepts. We currently use concepts very sparingly, but we could improve on that. More type erasure. That's the thing we did very successfully in certain parts of the software where we register the services, and using type erasure there, saved 8 to 12% in binary size of the affected DLLs. We could use ranges to return collections. We have just recently made the switch to C++20, so we could make full use of ranges in Microsoft world now today. But it's a bit difficult. We currently have very good ownership semantics. I haven't talked about the interface for returning collections because it would be another talk of 1 hour. So I wanted to spare you that. But currently we have a very good ownership semantics on that, and ranges might lose that. One thing I personally find very interesting would be to use more coroutines, especially to extend the select statement to return a data generator instead of the eagerly fetched collection. Currently we have like store and forward or fetch and forward, and for scalability it would be nice to have the option to stream a database query result. Okay, and then I got some wishes which are still impossible to do with C++ today, but I'm hopeful. I tried to const expr the get references method, but it currently depends on things not possible as const expr. Especially, I have not found a way to implement the completeness check as a compile time function, because at compile time I can't compare the pointers, because this pointer is just not there. And I think it's currently not possible, but during the break, if someone has a good idea, I'm grateful. But reflection, which I often hear is an upcoming C++ feature, will make the check for the completeness unnecessary, because then I could just extract the reference members from the reflected class information, and I would not need to check if it's complete, because it would be complete because it's provided by the compiler. Okay, so let's wrap up the whole thing. Even C++03 allowed us to build a robust object-relational mapper, and I think we achieved all our goals. It was a bit harder than it would have been with C++20, with the features we have today, especially with the more mature compilers, which don't crash at the slightest imprecision of code. Yeah, but now in 2010 to 2013, we ramped up very quickly the mapping of the many tables. I don't know how many it were in 2010, but I guess it were like 500 and now 700. When we wrote most of the business objects, data access objects, and services, we would have benefited from Veredict's const expr. But now, yeah, there are nice additional improvements, but the pressure is gone. Because, yeah, we extend business object, yeah, okay, but we don't write 10 in a month. So, and looking back, we were able to compensate with good education for the developers and close supervision. So they always had some expert available to solve their problems and to keep them going. Okay, and also during the years which have passed since this phase, we have had only little problems with new language features, new compilers, new compiler versions. I remember I had to adapt code when the new compiler came up and the new standard features conflicted with others. They removed features. So code had to be reworked, but it was never a really big issue. But it's better to make many small steps than wait 10 years and then have to do a large step. So my recommendation is stay current. And last but not least, the object-relational mapper is still under active development. We still care a lot about performance, speed, RAM usage, ease of use, safety, good compiler messages, debuggability. There's something we can improve, and we will improve upon it. Yeah. And that's the end. Thank you for your attention.
I have a question. Why did you use the 03 version instead of the 20?
Because the 20...
C++ is 03 version.
Yeah, because
Instead
that
of-
was the newest version available in 2010. Because from 2003, the 03 version, until the 11 version, there was not a relevant development in the C++ world. And looking back, it was quite, well, some kind of a risk to put that much effort into C++ software, because it was not clear that C++ would have this kind of a comeback.
Yes, but it would have been much easier with C++ 20, wouldn't it?
Yeah. But yeah, we couldn't do it because it was not available. Yeah.
I see.
I saw that you've been using Visual Studio, as you mentioned.
Yeah.
That are you using other compilers as well?
Our target platform was Windows.
Mm-hmm.
And I think 10 years ago, we managed to use Clang as a second opinion. We are using Clang in our continuous integration as like verification, second opinion on the code. And we are using the Microsoft emulation mode of Clang because we have a lot of Microsoft-specific things still in the software, but we have managed, as I said, we have achieved C++ 20 compatibility recently, and we had to modify some code to achieve that, like to be able to use the two-phase template parsing. Required some modifications, but it was, as I said, mostly I did the conversions to the new compiler versions, and I think C++ 20, I think it took me 3 days for everything. So it's not that hard.
Mm-hmm.
And then now we have the Clang as a second opinion, and we look at the error messages or warnings the Clang produces. Sometimes when we don't understand the error messages of the Visual Studio compiler, it sometimes is not very informative. It says, well, this instantiation failed. Yeah, okay, and how do I get there? So it's missing the template instantiation trace. And then I use Clang, and Clang says, well, okay, there's the bug. And then I fix the bug. And so I'm happy that we have Clang, and I'm happy that we have Clang compatibility, but we don't use it as a production, as binary production compiler.
One other question, because you showed like plenty of refactorings. How did you manage to do so big refactorings while you continuously build your product? Because that's often the issue.
We have students And they get tasks, refactor that, and they do it. They sometimes write tools.
Okay.
Yeah. Yeah, we did big refactorings. We restructured the whole source tree, for example. I think 2 or 3 times, because we wanted to better manage the dependencies and stuff like that, and we wanted to have we have developers who work in Java and C++ in both environments, and we wanted to make them as similar as possible without sacrificing performance or stuff like that. So, but we tried to structure the projects exactly the same. So you can navigate a Java project like you can navigate a C++ project. And therefore we had to move all sources around. And to avoid merge conflicts, we wrote a tool for the resorting of everything, and we applied it on 3 years branches.
Nice.
And we have regression tests, and they said, okay, it's green. So it works. It's a lot of work, but as you see, it's a lot of code. It's a lot of time, and we're continuously working on it, and continuously improving, and continuously delivering the software at least 3 times a year. And so, yeah, but it works, and it's fun. Yeah. And for me, it's really interesting to see how this system has evolved in this long time. So I've been working on this system for 18 years. And I think, for me, it's very rewarding to see, oh, now we can solve this problem. We had this 5 years ago, but now we can solve it. And we have a good solution for it. And so if you just jump from project to project, I don't think you have this kind of, oh yeah, hooray, I have waited for this feature so long, now I have it, and now I can refactor it. Yeah, that's really great. Okay, other questions?
Other questions? You can ask that in Polish, we can translate.
Yeah.
If the
Okay, so I
language is
have a
problem.
question, because you mentioned that you compensated for some lack of features by educating the developers. How did it look like? Is the documentation go write the code, or something better, more structured?
We had trainings, and we had every new developer had to write a business object, data access object thing in their training. And then they came across the problems, and we analyzed the results of the trainings and said, okay, that's the thing they do. Most developers do wrong. What can we do against it? And so we designed this check, for example, which I presented, or other things like. I always look for possibilities to statically check for errors you can do. And looking at this select statement, I presented a little part of. There was also a thing which could go wrong, and we put a static analysis in place to prevent it. So if a developer writes a wrong expression, the compiler would say, no, it's not acceptable. But that's hard work. You always need to analyze what people are doing, what goes wrong, why does it go wrong, what can we do against it. Does it answer your question?
Yeah, yeah.
Okay.
You mentioned that sometimes you can see some error messages from the compiler, and they are strange and no one can understand them. So what are you going to do about it?
Quite the same as in the answer before. The first is we got some experts, and the developer contacts the experts, which is most of the time it's me for strange template errors. And when I see a problem occur several times, I start to think, how can I prevent it? And with the means I have today, C++20 concepts, I would think along the way, along the lines of, well, what kind of concept could I specify? How can I restructure the code so that the error does not occur, or the error messages is more clear? In the ancient times, I put comments in the source code, reading like, if you got an error here stating I can't do what, can't resolve, can't convert X to Y, and nothing has something to do with what you just did, then it's probably that problem. That worked for a while, but then the compiler changed, and the error message did not occur in that line where I put the comment. So it was like moving target problem. And so for these things, yeah, you have to invent something and try it out and find out what can be a solution, what helps the people to not make certain kinds of errors or to better analyze. I got slides in my training. I do the lot of the developer trainings, and I got slides which say reading template error messages, how to read template error messages, because many people don't know how to do that. And yeah, that's the kind of help. And we document things, try to have good documentation for common errors, for how to use it. And we have example code. Like, okay, if you want to do something, there is a reference implementation, and we have a documentation, and it points to a part in the code where you can just see how it's done. And the developers look there and see, okay, I did it differently. And then they can see what's the difference and how they can modify the code so that it works.
How many people work on this code base?
Henning, how many developers do we have?
In Berlin,
Berlin?
around 150.
Yeah. I think when we started in 2010 with this ORM, it was 60. About 60, I would guess. And now it's 150. Yeah.
So how do you prevent you from being the bottleneck with like over 100 programmers, and you said you're most often the expert that they ask about their problems?
Yeah, educating new experts. Yeah, that's but that's really it's not a problem, but because we early started to educate other architects and try to put other people into the same position. And yeah, so now nowadays I only get the real hard problems. But yeah, we have some experts for C++ in our department now. And
So the other people deal with minor problems, and you get the most difficult ones, right?
yeah, it's like escalating up the chain. Yeah, each team has at least one architect, and the architect is usually also the expert for the tricky C++ problems. And if they don't know, we have a weekly jour fixe where we meet and we talk about these things, software design, C++ problems, how to solve them, and things like that. And that mostly that takes care of most of the things. And if someone just needs spontaneously needs an advice, yeah. Normally it doesn't take me too long, except they find a bug or an omission in the framework or in the library. I just had a Teams chat where a colleague asked, how do I do that in? And I said, well, okay, which version? Oh, I'm sorry.
Sometimes it's a spelling mistake, something minor, you know.
No, I don't see spelling mistakes. Yeah, I mostly see the hard problems. Yeah.
So, what static analysis tools do you use in your process? Like tidy or something like this?
I didn't get the question. What tool?
What static analysis tools?
Static analysis tools, the compiler.
Yeah, but before or after the compiler? No, stupid check or like tidy or something?
No,
else?
no.
Okay.
We have, we have the Clang CI, and we have most static analysis we do with just good settings of compiler warnings and errors. And the developers, some developers use Clang Tidy as part of their development environment. They use Visual Studio and have ReSharper C++ installed. And the ReSharper C++ has Clang Tidy as function. And so they have warnings and hints to improve the code. But we don't do it on the whole code base. It's mostly the compiler, which we use, and what we do, but that's it's a higher level, is we have a self-written tool to monitor the dependencies. So to make sure the architectural requirements or the guidelines are kept, and so that you don't just access across the system against all dependencies. So we have dependency monitoring, which verifies that. But apart from that, I have tried to evaluate static analysis tools, but I was not successful, because when I evaluated these tools, it took me 6 weeks to get the tool not to crash on our code. And then it analyzed and didn't find anything, or it found irrelevant things. Because in my experience, most static analysis looks for C-like problems, like memory management, dangling pointers, stuff like that. But we don't do that. We always use RAII. We use shared pointers. Well, sometimes it's compromise between efficiency and safety, but most of the time we go to the safety, choose the safe route, and we don't have most of the problems which static analysis tools are able to find. So I will give it a try again sometimes when I have time, but the problems and the bugs we have are not those which are found by static analysis tools, in my opinion.
Okay, guys. So I would invite you for a break. I'm sorry that I disturbed the question. I'm pretty. There's a food which probably is hot still, so please enjoy yourself.
I will answer questions.
Yeah, you will be available, so you can ask the question directly, face to face. So please enjoy the meal, enjoy your conversation, and let's buy 20 minutes for the next presentation. Thank you.
musiałeś to jakoś wpisywać tam w meta-obiekty. Że będę. Ale coś mi tam nie podobało mi się.
Chciałem któregoś użył tego, jakiś tam range.
No bo wtedy mówisz, mam taką strukturę i te składowe tej struktury to są tak naprawdę te encje w tabeli, nie? Masz przełożenie tabeli do jednej.
Teraz patrzę na te range i ja pierdolę. No nie, on tu mówił, że używają range. To jest 2020. Patrz tego flora, nie? To na przykład. Którzy masz int tu pałeczkę jakiś view transfer.
A to coś chciał zwracać. To jest... to jest...
Is a challenge how to. Okay, guys. I'm sorry that I disturb your excellent conversations. I see them a lot. My presentation will not be so perfect as the previous one, but I decided to do something ad hoc and to share with you guys some of the first thoughts, first impressions about CPP2. And there was already a first question before my presentation. And the question was, is CPP2 a new language or what is it? And this is an excellent question, and I hope I will answer that. CPP2 is an approach, kind of an experiment. And the experiment is about repeating the experiment which this guy did years ago, Björn Strostrup, in times where the C language was the most popular language. He thought about, hey, what we can do better, and he came up with the approach, a kind of experiment, where he proposed to create some, toy language, C++. And on the beginning, it was a tool called CFront, which kind of compiles C++ code into the C language, and the C code was then compiled by the C compiler, right? And that was the beginning. And later on, when the language became more and more popular, the C++ compilers become available, and the whole history starts. And this guy thought the same thing right now. and he thought, hey, how we can make the C++ even better, like 10 times better and safer. And he thought, hey, Björn did that once, let's repeat that. And he created CPP front, a tool that compiles the new syntax. And it compiles it into the C++ code, which then can be compiled by your preferred C++20 compiler. And the whole thing is very important for the C++ community, to be honest, because Herb on the CPP conference explained why this is important, and to be honest, I missed that. And it happened a year ago, and the whole story started with the US executive order from the United States president, and it was about cybersecurity. And in this document, there is a sentence which is pretty bad for the C++ and C developers, and it states that there are some languages which are unsafe, and in parentheses, for example, C and C++, and these were the only language they listed. And the whole document discouraged using C++ and C in applications where the cybersecurity matters. And that made me think and explain a little bit why there is so much fuss about Rust, like in last months, why there's fuss about Carbon language proposed by the Google. They propose a new language because the C++ is perceived as an unsecure language, and they see opportunity to propose something else. And what is different with that approach? So the CPP front can handle both syntaxes. Help call it CPP2 and CPP1 syntaxes. So you can take your code, your current code, put some lines of CPP2 syntax, compile that with the CPP front, and after that compile it with your compiler, and it will work. So it can help you somehow iteratively introduce the new syntax into your product. But before you will jump and rewrite most of your code, this is Herb call it hilariously experiment. So it's kind of experiment where everything is is a subject to change. And to be honest, if you are a sane person, you should not use it in your product, right? So, but it brings some really cool stuff, which I would like to discuss. And Herb explained what was his motivation. And his motivation was to bring good defaults in the first place, which will make the C++ better. Because Herb and other guys which are in the C++ committee, standardization committee, these are the guys who also teaches C++ and all the good rules and everything. And there are plenty of rules which we need to teach people how to not to shoot yourself in the foot or back or head, right? So, and he thought, hey, maybe we can propose a syntax which will be easy to learn, which will have good defaults and work better. And that's his approach. Here you have the GitHub repository where they have posted, but I will show you more stuff later. So, answering the question, this is an experiment and it brings new syntax, but the whole approach is to make a C++ better. So the results of this experiment will be brought into the committee hopefully making the C++ better. So it's all about C++ 20 and 23 and future version of the C++, more than jumping into the new language. How the CPP front is used, the usage. So when you run help on the CPP front, you will see something like that, and there's like the most crucial switch is a -p is pure CPP2 syntax only, and it will block you in using like the CPP1 syntax at all. But it's not about that. The power of the CPP front is in running CPP1 and CPP2 in the same code base. And there are also other switches which brings you more checks, safety checks, security checks, and everything that should blocks you in getting into the trouble in your code. So what is this new syntax? And there are a couple of interesting things. And when I showed that syntax to the to the others, they mentioned, "Hey, it looks like Rust, or it looks like something else," and it's right. Like probably, like most of the mainstream languages are thinking in the similar way right now. So CPP2 is jumping into the same. So here proposed to use the left to right approach of defining things. And what you see here is that the classic main is defined by the, you are defining the name main, which is a function which in this example like takes nothing as an argument and return int. And that thing is defined by that. And maybe, and the same goes with the variables. So when you want to define an x variable, which is an int, and which is equal to 42, you are doing it right in that way. And you can initialize, like define and initialize in one expression. So you are using that. And I will show you at the moment what C++ code will be generated out of that, using, of course, the Godbolt, which is the perfect tool for showing that. And, of course, you can use the normal classes from the C++ currently used. So you can define the Z variable, which is the standard vector, which is initialized with the numbers 1 to 5, and that's it. And at that moment, I need to explain you something more, because I told you that it's like very, 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 very experimental thing, and currently it has only functions and no classes. Like it has no possibility to define classes in a new way, but you can pretty much do a lot with the functions. And so please remember, only functions, no classes at the moment at least. So I will need to make it larger. Give me a second. No. Here is the right switch. No, maybe better, but still okay, and the same. So what you are seeing here is on the left is CPP2 syntax, and on the right you see how the CPP front compiled that into the C++. And as you can see, for example, main is like, on the current example, is a representative of the function. So one thing you can notice is that there is like no discard by default. So all the functions have no discard added by default, right? So you see how the x variable is initialized. This syntax only gives you auto in the proper place, and the type is deduced. And the vector is like any other thing you would expect it. So as you can see, like nothing happened here, which is like magic, but it already brings you a benefit of having some cool things. And maybe I will show you something. Oh, no. And again, so as I told you, it's all about safety and security. So what you see here is that X is uninitialized, and in the line 7 I'm trying to use it. Of course, your good compiler will warn you about that, but warning is not enough. So here is by default is an error, and there are like even more rules about it, but this is kind of example what defaults we are bringing to the language. Some known expressions are just forbidden, and that's pretty it. If you have any questions, just Okay, so parameter passing is probably the most discussed thing in the C++ community, and we probably spent tons of hours learning how to pass a value. Should it be, should the x should be passed by value? Should we be const reference, maybe normal reference, maybe a value reference? And what about the forwarding, right? So like plenty of discussions, and of course Herb already proposed something to the language which brings you those 5 special words which you can put before the variable. Like when you define the function and you are passing the int, you can define in the function signature that this function is this variable is an in variable. So the intention is passed to the compiler, which based on the type, its size and everything, can deduce what you wanted to do with it. Usually it's like const reference, but if the type is small, it just passed by value. In and out, it's usually reference, so the variable that you can read and write to it. Out variable, it's a variable that you can only write to it. And this is like interesting. It's not implemented in the CPP front yet. Probably it's hard to do it right now. But this is really interesting. And you have also move and forward, which becomes a value reference, but the context is important. And how it looks, and what I bring you here is a link to the Herb Salter proposal, which you can see what is already proposed to be added to the language. And wait for it 5 years, for example. Hopefully not. But yeah. So where is it? So, I will just present you something. So what you see here is just a function, like function f, which takes a variable argument x, which is anything. This is like this is kind of a template thing. Of course, it is using auto there. So, and what it returns is also deduced. So that's why it's auto. And here, after the equal sign, you have the definition of the function. And I will show you what will those new words put it in the proper place will do. So when I will put here n, it will do nothing because the n is a default. So sorry, but so what we are interested in is the type of the argument, right? So, but when I will put here in and out, it will change to the reference. So we also have a move, which becomes what it's supposed to be, and we have forward, which brings to nothing. But the important part here is that those words are some kind of hints given to the compiler. So when we are using our value reference to a type, it is not clear for the compiler if you are going to forward it or our intention is to move it, right? And if you explicitly state it here, and when you won't do it inside the function, this means it's an error, right? So it's easy for the compiler to spot your mistake by giving him more information about your intention. So that's what is here. And I know that it's not about the arguments, but I will show you a pretty neat thing. I hope it will work because to be honest, I didn't check it yet. So I told you that it's a kind of experiment. So forgive me if it won't work, but I saw her presentation and his example. So the usual case is so if you are writing a function which returns one value, it's pretty easy function, right? But the common problem becomes when you need to return multiple values, right? So that's why tuples came into the play into C++. But the tuples usually are not descriptive enough, right? So when you have a tuple with 10 elements, it might become a little bit tricky to use it, right? So what people were doing were creating structs, special structs with proper naming with the variables to make it more descriptive what it returns, right? So the CPP front is doing that, by default. So for example, if I wanted to return I, which for example for me is an int, and j, which is, I don't know if it will work, but hopefully it will. And it didn't. But let's give me a second, and I hope I will make it working. So I can assign it here to 42, and j. Yeah, woohoo! It's working. So it's really funny. So I don't remember. Probably I need to write return. I don't recall it correctly, but I will check it. Yeah, it is. So really interesting thing happened here. So what CPP front did is exactly what you will probably do. if you are willing to make something more descriptive, so it just create a struct with proper naming, and it just, it's just returned, and it does that automatically. You don't need to spend time on it at all. And what else is important? Those names, I and j, are available. You don't have to create a variable which you will be returning, because you already explicitly stated here, right? So I and j are just those values you wanted to return. So here it is, and it makes everything simple. And of course, you can use on that structure binding. Structure binding? Yeah, I see some nodding, but let's make it explicit. So I told you that you can mix things, right? So CPP1 and CPP2 syntaxes. So for sure I will write a normal main function which will work here, because I didn't add the -p switch, so it will work. So I can so it's a f, and I need to write something. Yeah. So I don't know if you know that structure binding, but I will explain it shortly. So structure binding just looking at what f is returning, and if is able to match some first and the second element, and in that situation we have a struct with I and j in it, you just take it out of it, right? And you can use here a pair, a tuple, as long as it has two elements, it will work, right? So, and this is not CPP from, this is like normal CPP 7 thing, C++ 17. So, so still, it's all about creating a syntax which is simple, which is easy to learn, easy to use, and which will be in the end compiled in the normal C++ with some tricks in it, and helper libraries that makes the thing happen here. Any questions to that? Loops. So the loops, do you see what is here? Because I just realized that it's like pretty dark. Okay. So loops change a lot. So that was like a thing that surprised me a lot, because I was like happy with 4-range loops, which were like introduced in C++ 11, but nevertheless. So here is like the similar approach with like defining, and I will tell you in a moment what does it, but for every element in V, we wanted to run that. And you will learn it at the moment, like in a moment, that this defines a lambda. So like this is the syntax for the lambda done in place. So that's it. And you can also define here if you want to modify thing, or only, here is the default, so in, right? So we explicitly say, or in this example implicitly, because it's default, that we are not going to change E, right? So we will only read from it. But if you wanted to somehow modify it, we only need to add here in and out to inform the compiler that, hey, we were going to change it, and you can do it in a spot. So I will try to show you that. Come on. So as you can see, the the new for is compiled into the old for, as you can expect. But you might not be familiar with that because it's I don't remember in which version the initialized part was added. It's probably C++20 or something like that. So here, because that part is like normal, like 4 range version, and here we have like initializing part. So here we just are taking v as a value reference, and we are doing something on that. So we are like looping at it and doing something with it. And as I told you, when I will add here in and out, it will be changed in an outer ref without const. So then I'm able to modify it, and it will work or not. Yeah, sorry, I'm just learning the new syntax. I don't know if that will work either, but let's try it. Yeah, it was. So as you can see, like it brings some new syntaxes. I don't know, to be honest, why. Probably because of introducing some kind of consistency into the approach. So, but we will learn that probably soon. And the lambdas. You already seen something similar, and so we have the code on the left, which is the main, right? But in the main, it's something like that, and it of course compile to the initialization of the L variable, and which is the lambda. Nothing special, right? And what appears here, it's slightly different to how you define the function, and the only difference is that you put colon here, which might not be like the good thing, because this is like tiny change. And to be honest, I've been like for the first couple of hours really struggling how to define simple things because of those slightly changes in the syntax, especially when you are familiar or used to some other syntax, right? So those small changes makes it difficult. And there is like the question to you guys: where is the capture part for the lambda? How to define that? Any ideas?
There are none. There are none capture.
There are none. Probably lambdas will be kind of useless without the capture, but yeah, that might work for some cases. Any other idea? So when you want to, for example, add this x here, and let's assume that we want to capture it. I know it's weird syntax, and again, I didn't test it, so sorry if it didn't work. So there you go. So that's the syntax when you want to capture something. And I don't know if it's make things simpler or not, but it's just the way it is. And
it's a bit funny because the x is also in the parameter.
Ah!
But it works, apparently.
Probably it's kind of what you see here is kind of transpilation from like CPP2 to CPP1. But to be honest, to check if it succeeds, we need to compile that. And Godmode is not doing that at the moment. I was doing that on my machine, but unfortunately I cannot show you that here. But nevertheless,
after the return.
so I will change that, not to but good catch. Yeah, but also the funny thing is that I'm not using the I here, so that's. And of course, in the proposal which Herb brings, like having the in value which was not used inside the function is also an error, right? Because you said, hey, I asked it as an in value, and I didn't use it, so you probably were mistaken for some reason, right? There are warnings that in current compilers, right, which warns you, hey, this variable is not used, right? So this is like all about that. Any question to that?
I would like to see what it's after.
Oh.
That's the interesting part.
That's even better.
Yeah, even when
We can
you have
either see the main
when you
of
have
this
the X in the parameter list.
Oh, okay.
But I think it would get it right.
Yep.
Yeah, it's okay.
But I currently I mess even.
Yeah, but the I is not defined.
Yeah, but it is.
Okay.
So
It was $1.
yay!
Now it works.
It should work. It should work. Yeah. The dollar symbol surprised me a little, even more. I didn't test it yet, but let's do it together. So I would just include IOStream. I know that you don't like it, but let's keep it for now. Oh, not that. So let's say x plus 4 is equal, and if I get it right, it should calculate that. But let's check that. It's doing something. Yeah, it's doing exactly that. So weird, but yeah, but I've learned that like today, so I didn't play with it more.
Is it expected to do?
Could you repeat the question?
Is it expected
What expected?
to string that?
So what it should does here, right? So we have an x variable here. So what I'm saying, I did it on purpose just to clarify what we expect here, and here we expect to have a result of like 59, right? So here it will calculate the 59 and we'll change it into the string, and everything should work. Yeah, or not? Should or not?
Yes.
I didn't test it, I didn't compile it, but I just looking on what the CPP from compiles to. Any questions to that?
I think it is confusing because these parameters, there is x so many times.
So sorry, I should use like proper wording here. This is like for the examples.
Too many x's.
Don't use x's too many times in your code, please, because it confuses people.
Confuses the compiler.
Compiler feels like fine, I think, but the people that needs to read it, no. Yeah. And that's the really cool thing. And it's so cool that I even contribute to and propose a change to the help CPP front, and I will show you what the change is. But
I think there is a spelling mistake. It should be function, right?
if I function,
N is
yeah. my mistake. But nevertheless, what I wanted to show you here, what is this UFCS, because it's used by the abbreviation only. So you should be able to read that already, right? So my file is a variable which is initialized by the result of fopen, right? Fopen opens the file. It's a POSIX function. The function is the file is called xyzy, and we are going to write to the file, right? And have you used fopen and other functions? Yeah, one person? No, not much. So normally, what you receive is the pointer to the file thing, file written in capital letters. And when you wanted to write to the file, which is pointed by this pointer, you need to call special functions like, for example, fprintf, and the first argument shall be this pointer, right? So you are going to write to this file, and the other arguments are the content you wanted to write to the file. And maybe I will highlight that. So as you might expect, fprintf is a printf for the files, obvious, right? But what happened here? So what happened here is that we are using the result of the function, which is like file star, right? So the pointer to the file. And we are running the method fprintf on that. And I promise to you that a file has no method fprintf. So what's happening in that moment is that the compiler, that's why it's called unified function call. When compiler sees that, it checks, of course, if that my file has that method, but if it's not, it tries to use that my file as the first argument of the function, right? So in that context, it matches, right? And of course, in the end of the life of my file, you should close it. So again, in the POSIX, the fclose function should take a file pointer as the first argument, but you can call it in that way. So and why does it matter? Because it might look silly that you're okay. This is like syntactic sugar for something, but there are at least two reasons. One reason is to give your IDEs a helpful hand, and IntelliSense a helpful hand. So when you have my file and you press a dot, the IDE knows, hey, this is pointer to file. What can I do with it? And it can list everything that you can use pointer to file with, right? So it's helpful for the IDEs and in IntelliSense. And the other thing is generic code. But when you are writing that currently code which is generic, so it's using templates or something else, I don't know what you can use, but you always have to think about if the type which you are using will have a function which will be called on it, or if there is a method inside that type, right? And if you will bring the unified syntax call, you no longer need to care about it, because the compiler will handle that. And of course, there's a proposal made by Herb, and I will show you what the magic is behind that, and the magic is not so horrible because there is a macro used here, right? And that's why it looks good. Yes?
I think the universal function call syntax was a proposal by Bjarne himself.
Yeah,
And it was
you are right.
rejected. It was rejected.
It was
for
rejected.
C++.
It was rejected. There was like a kind of a split in the committee. Some companies were, were willing to do it, but some were not. And you might think, hey, what's going on here, right? Because you are not showing the cool part here. So, worry not. I will show you. So, okay, and this is it. So I will show you. This is like the Herb repository, and I play with it a little bit. Yay! Now I need to again make it bigger. No, it's not that file. Sorry, I will confuse you even more. So there is an include. Yeah, that's what this is the file which is included to every generated file, and here you have a magic. And it's pretty simple, right? So everyone are familiar with it or not? Do you know what it's doing? So there are a couple of interesting features used here, of course. As I told you, CPP front works on the C++20 compilers just because of that. So if context, you should know from C++17 already. So it's an if which runs in the compile time, obvious thing. And here is like the new thing. So requires is from the concepts. So it just tests. Okay, this is the simpler one. So _0 is a function that takes no arguments, just because these are the macros which are not, which should not be used. But nevertheless, what it does requires just testing if that code inside the braces will work or not. Right? So it's like running the compile and checking if it's failed. If it is, it just returns false, and that's it, right? So, and what it does here is, check this out. So we have like function name here and the param given here. So what it does, it's okay. It returns the lambda, sorry, which takes the object, and the object becomes the param1, right? So the param1 was the argument, right? So, and what it does here is, first approach is it's saying, hey, maybe it's an object with the function as a method, right? So it's just saying, hey, let's treat it as an object, and it's just, forward the type of the object here. So here you will have the exact thing you were passing here, and we are just running a function here. If it works, then the function gets here, and this is the thing which is returned, so the function will be called, the method will be called. But if this will fail, it just goes here and run the function, the func name as a function with object as the first argument. And in this more generic one, or like advanced thing, there is like ellipsis used, so you have parameter packs. Yes?
Yeah, when I look at that, I think I should call the committee and ask for a proper support of empty parameter packs.
Yeah.
Because
yes.
that's what's
yes,
missing.
Exactly. It might be that, or maybe maybe macros failed here, because maybe
no, you can put
yeah?
the
Okay.
param1
Okay.
into the
So-
variadic. I did that already.
Okay.
And
okay.
it's quite the same.
I'm not the fan of the macros, so I just take it as it is. But you can contribute, and if you will be able to mesh that, you are welcome. So that's what's happening here, right? So crazy stuff behind the scenes, but the cool thing is that something that was proposed and was rejected because it brings too many dangers in old code. It's already implemented using the features which you already have in the language, which is pretty cool. Unfortunately, this feature from Herb, it's not doing the coolest part of that. And I was so angry about that. And what the C++ developer is doing when something is wrong in the open source project. I don't know, Philip. It contributes. So I write the most important thing, method chaining. So I'll just show you. So that syntax will fail currently in current implementation of Herb. But in my implementation, it just creates the beauty of that. So, and that's pretty cool. And I will show you an example of why it's cool. This is not on that proposal, but on the second one. So there are like two ones. And in one, I put more examples. So, yeah, here. So that's what I showed you. It was the starting of chaining of methods called on the object. And what I found in current implementation is that when you call a normal function, it did not start the chaining or anything. So what I implemented, it's the fopen thing you've seen before. I just make it simple, but having that in mind that we can do some more crazy stuff, I just introduce the on-scope exit function, which just pack that file pointer into the unique pointer with the proper deleter, which is a fclose here, right? And we can do the crazy stuff. So I'm just calling fopen and run on the pointer file pointer on scope exit with the fclose, which will create me a excellent unique pointer in the first place. And later on, I can just run f2 get to get the the row pointer again and call fprintf on that. The cool part is that it's clean after itself, right, on the scope exit. And of course, the manual thing still works. And we can go even further with that. So, for example, we can, of course, store that variable, but we can do one-liners, of course. And if the fprintf would return file pointer, it will, you can go even further, but it is not. So I'm encouraging you to contribute to that because it's pretty fun to do that. But nevertheless, what I'm showing you is, no, I just broke it. I'm already on the end. So I will just show you the last thing here, not to bore you more. Herb also proposed already to the community is and as keywords. Is a kind of query that you can check the type or something. And as is like a casting thing. I recommend reading what Herb or watching his videos about is and as. It's one of his last videos. So what's happening here? We just run inspect on the X, and we will produce stud string as a result of that. And what's going in the inspect? We check if it's int, and if it is, we just return that. If it's a stud string, we just return that. And if it's something else, we just return the string that informs, hey, it's not that. And I will show you what the magic is behind that, and it will be probably some crazy magic. So I won't show you that. Don't worry, I won't get into more details. So, nevertheless, these are the simple tools and solutions here, but really complex things here. And you can write really interesting things here. Like for example, Herb was showing that the is thing is a kind of enabler for switch cases, structs, where you can check not only numbers, but you can, for example, use strings or something like that with the using of is, which is pretty cool. But I will not get into that because I promised to have short presentation and it's already long presentation. And yeah, so just to get it, it's checking if it's int and return that string. I already go through that. So what's next? What you can do next? So for sure, you should go to the Herbstadter repository and check what's there. There's a link to my branch, which I pull request, which I requested. So if you wanted to play with the chaining, currently you need to use my branch. I made a CPP2 example project, which is using CMake, which downloads the CPP from Herb, compile it, and do like all the magic, compiling CPP2 to CPP1, and compiling with a normal compiler. So if you wanted to play with it and don't know how to start, just use it. And here's the link to the Godbolt. Maybe I will just show you that as the last thing because you might not find it. So here you can select multiple compilers, and one of them is CPP-X-CPP front, CPP2 is now. So if you want to play with it on the Godbolt, you need to find that compiler, but you need to remember it only compiles into the C++, and that code is not compiled on the Godbolt. So you might play a little bit with it, but it's not all. Okay, guys. So I won't bore you more. So thank you for attention. Any questions at my last slide? I'm glad that my description was so clear. Yeah, well, there is a question.
Well, I mean, it was great, very funny and instructive. So how does it compare with Carbon and?
That's an excellent question. So the Carbon, is going to the similar approach, and this the Carbon language is also an experiment. The main difference is that the Carbon language exists on the paper, and there's no working prototype, and CPP front have working prototype. Yeah, that's the difference.
You mentioned that C++ is not is a little bit dangerous because of cybersecurity reasons.
Look at those faces. Those faces show you that those people every day.
So what can we do about this to make it safer?
Yeah, that's a really hard question, to be honest, because Carbon language, there was a decision by the Google to create a Carbon language just because they were struggling with the C++ standard committee with some changes into the language, and probably they decided to go with other path just because they have to struggle, and there was no agreement with the committee. And as you already mentioned, there was a proposal, for example, with the unified function syntax call, and was rejected. And so there were really good ideas in the past which were rejected, and that make Google decide to go with the kernel language, which is like completely their thing, and they can't do anything about it. Any other question? Okay, guys. So I'm really glad that you come today for this meeting. I'm looking forward for your feedback about what happened here, if you like it. If you want more meetings, meeting like that, what kind of topics you would love to see here on those meetings. You can catch me everywhere in the social media. So I already catch you probably on LinkedIn or somewhere else or whatever. Whenever you see Poznań.cpp or Wro.cpp, you can be sure that when you write there, I will read that. So no worries about it. So and I'm looking forward for that. So and I'm really thankful for the IVU Traffic Solutions, right? No?
Traffic Technologies.
Traffic Technologies, sorry. For sponsoring this event and making it happen, and to inspire me to just start the community in Poznań as well. So once again, thank you all, and bravo for you guys. Well, everyone online, thank you for joining us, and I will be posting those videos on our normal channels. Thank you, and bye.